Okay, this is the thickness of currency, part deux. And you can see the beautiful octagonal currency from the late 1800s France. There's a couple of pieces of information we actually need from here. And one of them is the fact that it's 36 millimeters, which means that it's 36 millimeters across. And because it's an octagon, that means that 1, 2, 3, 4, 5, 6, 7, 8, all 8 sides are exactly the same. And it is 24.2 grams. So I'm just going to jot that down over here real quick. So just so I don't forget, it's 36 millimeters and 24.2 grams. Okay? And we want to know the volume of this octagonal coin. And the other thing that we need to know from here is the fact that it is silver. So this is a pure silver coin. And if we look up the density of silver, we find that it is around, actually I'll look it up. Okay, I see that it is 10.5 grams per centimeter cubed. Okay. So it's 10.5 grams of silver in 1 centimeter cubed of silver. So in other words, we had a cube of silver that was 1 centimeter by 1 centimeter by 1 centimeter, that this mass, if we put it on a scale, would be 10.5 grams. Okay, and I can tell this is 24.2 grams, so it's definitely going to be more than 1 centimeter cubed of this. So for every 24.2 grams of silver, there is blank centimeters cubed of silver. So this is 10 to 24.5. So it's around 2. So if I take out my handy dandy calculator, 24.2 divided by 10.5 is 2.3. So this is going to be 2.3 centimeters cubed of silver. So that's how much space this coin takes up. Okay, so now this gets a little more complicated. What is the thickness of this octagonal coin? All right, so this is where there's a bunch of different ways to do it, and a few of you actually came up with ways that I had not even thought of. I think the most important thing to remember is that all of these sides, although that is a terrible picture of an octagon, all of these sides are exactly equal to one another. Okay? And so we know that the distance across is 36 millimeters, which means that the way that I thought about this is I just said, oops. Okay, let me try this again. So I just said, okay, look, it's an octagon. And so if this is 36, well, then I could just make it a square with that these 4 triangles have to come off to make it an octagon. And those have to be right angles. So, and 2 of those right angles would make another square. And those squares, if I could figure out what the dimensions of those squares are, I could just subtract them. So I'm just going to say, look, I'm going to pretend that this is a pure square. And I know that's length times width, which would be 36 millimeters times 36 millimeters. So the area of the square, not the octagon, would be 36 times 36. And 40 times 40 would be 1,600. So this needs to be less than 1,600. And it's 1,296. Somewhere around there. Now remember, this is, millimeters squared. Okay, now I got to subtract these things. Okay, so if this is 36 all the way across, then this is 12, this is 12, and this is 12. So in other words, and if I combine all of those squares, I have a 12 by 12 square and another 12 by 12 square. Okay, so I'm going to subtract, well, 12 times 12 is 144, and 144 times 2 is 288. So my area of my octagon, I'm not going to try to draw a small one, is 1,008 millimeters squared. So we've got an area of 1,008 millimeters squared. And the problem is that up here I've got centimeters cubed. So I need to convert one of these to either centimeters or millimeters. And you might say, oh yeah, well I know that 10 millimeters is 1 centimeter. Alas, 10 millimeters cubed does not equal 1 centimeter cubed. That would be an incorrect statement. And if I want to think about it, I kind of need to go back and make my 1 centimeter cube. That means that it is 1 centimeter by 1 centimeter by 1 centimeter, which is the same thing as 1 centimeter cubed. Okay? But that also means that this cube is 10 millimeters times 10 millimeters times 10 millimeters, which means that that is equal to 1,000 millimeters cubed. In other words, 10 times 10 times 10, which is 1,000. So I can already write that as a for every statement. I can say for every 1,000 millimeters cubed, there is 1 centimeter cubed. And then from here, well, I don't know, which one do we want to convert? Well, we decided on the cube. So we've got for every 2.3 centimeters cubed times 2.3 times 2.3, there is 2,300 millimeters cubed. Okay, so now I have millimeters and millimeters. One is squared, one is cubed, not a big deal. Well, I know that the volume of the coin was equal to area times the height, which is the thickness. That's what we're looking for. So the volume was 2.3 centimeters. Or I'm sorry, 2,300 millimeters cubed, and that's equal to the area in millimeters, or some version of that, 1,008 millimeters squared times the height. And I'll give myself a little bit of space here. I divide both sides by everything but h, so this is 1,008 millimeters squared, 1,008 millimeters squared, and you'll notice that millimeters squared and 2 of those values drop off. So this is 2,300 divided by 1,000, so it's going to be about 0.23. 1,008, and that's 2.28. So the height is 2.28 millimeters. So less than a centimeter. Okay, so this one has us kind of looking at what a silver atom is, and you'll remember that we talked about that the silver atom is basically a sphere, and we know that the volume of that sphere is 4/3 pi r cubed. Okay, and I like to liken an atom. The idea of an atom is like Violet from The Incredibles. When she throws her force field out, it kind of encompasses her. Think about an atom like that. Like we've got this nucleus at the center, and then there's a big force field around that nucleus. That force field that's around Violet is kind of like the way that an atom looks, or the way we think it does. So the volume of this sphere is 4/3 pi r cubed, and I looked up the radius of a silver atom is 172 picometers. Okay, and I'm going to do something a little different here. I'm going to switch this out here initially because our volume up here, right here, is in centimeters cubed, and I don't really want to mess around with that necessarily. So I'm going to change this to centimeters right now. So I know that there are 100 centimeters, or 1 times 10 to the second centimeters, in 1 meter, and I know that there are 1 times 10 to the 12th picometers in 1 meter. So I know that there are 1 times 10 to the 10th. In other words, I'm losing 2 there, and I'm losing those 2. 1 times 10 to the 10th picometers in 1 centimeter. And that makes sense because these are small, and this is a bigger unit. So centi is bigger than a pico. Okay, so if I got 172 of the, if I've got 172 of these guys, picometers, that means that I've got a very small amount of centimeters. So to get from here to here, I'd multiply by 172 times 10 to the negative 13th, because I'm going to have to negative 12th, sorry. No, 10 to the negative 10th, sorry. So we're going to drop those two. So this is going to be 172 times 10 to the negative 10th centimeters. Okay, so backing up over here, we've got 4/3 times pi times a really small number, 172 times 10 to the negative 10th centimeters cubed. And I got a pretty good idea of what this is going to be, but it's going to be a big number that's made a lot smaller by this 10 to the negative 10th. So 172 cubed, well, 2 cubed would be 4, and 2 cubed would be 8. So this has to be less, and that would be, so 20 cubed, or 200 cubed would be 8 million. So this would be a number less than 8 million. So 172 times 172 times 172 is 5 million. So this is 5 million, I'm just going to do that, times 10 to the negative, now this is where it gets tricky, we've got negative 10th, and we're adding 10 more zeros twice, so this is 10 to the negative 30th, and if I swoop this out and come back to here, then I'm losing 6 places. So this is going to actually be, and I'm just going to make it a little bit easier, 5.088 times 10 to the negative 24th. And then multiply that by pi, so that's like 15. And then multiply that by 4/3, and it's really almost like multiplying by 4, right? Because pi and 3 are almost the same thing. So this is 21.3 times 10 to the negative 24th, and the units here, sorry about that, are centimeters cubed. So this is how big one of these atoms is. Okay, so we know that that's one atom. So for every one atom, there is 21.3 times 10 to the negative 24th centimeters cubed. So remember what that means. That doesn't really mean 21.3. It means that this decimal is 0.21, and before that there are 22 zeros. So there's a lot of zeros in this thing. Okay? And we want to know how many atoms there is in this whole thing. So for every blank atom, there is, as we said, it was 2.3 centimeters cubed. So that's about divided by 10 times 10 to the negative 24th. Times 10 to the 24th, because we've got to get rid of those. So this will be 0.1 times 10 to the 24th, or 1 times 10 to the 23rd atoms of silver, which is a lot. It's a number that we can't even really comprehend, and that's just in this one coin. All right, and then we said, okay, look, that's a bad assumption. So really, 75% of the space, 75 of 100 is silver, and 25 is empty. And we don't care that it's that. We care that if there was 100, there would be 1 times 10 to the 23rd. So this is 1 times 10 to the second. So to go from here to here, it's just 1 times 10 to the 21st times 1 times 10 to the 21st. So this would be 75 times 10 to the 21st atoms of silver. Okay, I hope that helps. I know that was a long video. And I'll see you tomorrow.